Welcome. We're going to walk through some data processing for our required practical on the acceleration of freefall. For this one, we were using some paper slips where we dropped the paper slips of different lengths through a photo gate, and we looked at the time it took the paper slip to fall through the photo gate. That's a little background on this. This is going to be a little bit of a longer video. It's going to be really specific to what we were doing. Sometime in the future, I will try and make more generalizable videos that just show the basic skills presented in this one. But for now, I just wanted to make one that got us through everything. Now, our goals. Oh, and first and foremost, wherever you found this video on Canvas or school website, wherever we're using now, that link or that place should also have a link to this spreadsheet so that you can start with the same data and kind of go through the processing with me and then go back and do it with your data. So first, I want to talk about our goals for this time. So first, we're going to find the fall time for each trial. The reason why is because when we dropped it through the photo gate, it started timing once it started blocking the laser for the photo gate, and then stopped timing once it unblocked the laser. We then dropped the piece of paper a second time without stopping the overall timing, and so we had a start time and a stop time. So for each of these fall times, we actually have a start time and a stop time, and we need to actually calculate the fall time for the paper. So we're going to start with that. Then we're going to look at the average of the fall times. I have a little typo here. Fix that real fast. We're going to look at the average of the fall times for each length, and then we are going to find the uncertainty for those average fall times. Last but not least, we will check and see, or we'll graph our data and check and see if it needs to be linearized, which will then queue up a whole another set of things we need to do if it's nonlinear. If it's linear, then we're pretty much done. But if it's nonlinear, then we need to graph the linearized data, linearize the data and then graph the linearized data. What's not mentioned in all of this is also whatever our final graph is, we need to insert min and max trend lines or slope lines so we can calculate uncertainty and slope. All right, feel free to watch this on, I don't know, 2x speed because it's going to take a little while and I won't have time to properly edit this. Okay, so to start off, we have our raw data here formatted. So I've put the length up top, I've put the labels for each of these with the units. Notice that there are no letters down here so that our spreadsheet can treat this as a bed of numbers or an array of numbers. All right, so to do the fall times, I'm going to start off by telling it that I'm going to insert these titles so that I have them ready to go. You can ignore the linearized ones for now. But I'm going to insert these titles so I have it ready to go, and now I'm going to say, okay, so for the length is going to equal just this length up top. So I'll hit equals, and then I'll click the cell up top. I'm going to do that again. For the next length, I say equals, and I click the next cell. And so it's linking it to that cell. That way, if for some reason I was like, oh, this is actually 0.06 and not 0.05, it'll auto-update down here as well. Let me undo that real fast. Okay, once I do that once or twice, I can actually highlight my cells and then just fill down. If you're having trouble filling down, then just do it manually each time. All right, so that's our first step. If you got that, good. If not, pause, rewatch it. Next step, we need to find our time for time one. So if this was the start time and this is the stop time, then I just need to subtract those two. So I'm going to say equals. I'm going to click on this cell, and then I'm going to say minus, and then B3 is the other cell we're subtracting. Now usually what I like to do is double check that I'm doing this correctly with a calculator on the side just for one or two of the calculations to make sure I'm not making an error, because sometimes we make errors on spreadsheets and it's hard to tell. So I'm just going through and I'm doing the stop time minus the start time for all of those. Now I can do that again for the second row, equals, and Google's already starting to realize, oh, maybe you want to do C4 minus B4. Let's see if I can get it to access that again. So maybe I want to do C4 minus B4. Cool. I'll go ahead and do that and select that. Now, the other part is that because I've actually already set this up for this one, I should be able to just fill down in order to see what's going on. Okay, so now that I've filled down for that one, I'm going to go ahead and fill down for this one as well, and fill down for this one as well. Now again, I like to do a quick double check, so I'll double click on this cell to see it says G4 minus F4, and we can see, yep, that's correct. So it's taking G4 minus F4, and we get our time. Next, we're going to average those times. So again, I'm going to say equals, and I'm going to click on this length. The reason why I keep having it set equal to the previous one is just, again, so that if for some reason something needs to change, I recollect data, etc., it'll auto-update everything for me. Now for the average time, I'm going to go ahead and click equals, and I'm going to use the average function. So if you type in the word average, it'll pop up as one of these options. So we'll select average. Now it's going to put a parenthesis there, and now you need to select the values you want to average. So I can say this cell, comma, this cell, comma, this cell. Alternatively, I could say equals and then say average, and I could just highlight those three cells, and it will put them as like a single set of data as opposed to listing them individually. Regardless of how you do it, you could add them all up and divide by 3. Just be careful that you use parentheses. But I'm going to go ahead and highlight those things and fill down. Now I'm looking at this and I'm seeing, okay, so for the shorter length, I actually got a greater time. So something's up with my data up here. So let's go back and double check it real fast. Yeah, so I made a mistake here. I actually said my start time of 3 minus my stop time, so I didn't check that properly. So I'm going to erase that data and say equals, and I'll say stop of 2 minus the start of 2. Cool. And then my guess is that all of these are now incorrect as well. Yep, so I'm going to go ahead and fill down my previous one. Cool. So that's again why we use spreadsheets, is that if we make a little mistake, once we find it, we can easily fix it. And now we notice that my average time has been fixed. I didn't have to fix everything over and over again. It just, you fix the one error and then it kind of carries through. Okay, so before we graph, we're going to calculate the uncertainty. First thing I'm going to do is I'm going to work in my new section down here for uncertainty. For this one, just like before, equals, and then I'm going to go ahead and say equals that cell right there. And I'm going to fill down. Okay, once you fill down, next thing we need to do is we need to figure out the max value and min value. So max time, min time, and what we're going to do is we're going to subtract the maximum minus the minimum and divide by 2. So we'll say uncertainty. Doesn't really matter how you organize this one. I just want the uncertainty next to my length because that's what I'm actually going to look at, versus max and min time matter a little bit less to me. So for this one, I'm going to first of all find the maximum time for each one. So I'm going to say equals, and there just so happens to be a function called max. So I'm going to say max, and it asks of which data values do I want to find the max. So I'm going to do this for each length. So I will go ahead and highlight all 3 times for the first length, close it out, and it will give me my maximum time. I'll do the same thing with minimum. So I'll say min, and then I will go back and I will highlight those 3 lengths, and it will give me the minimum time. So this is where I like to do a quick double check. So it's saying my max is 0.07915, and it says my minimum is 0.07582. So if I scroll back up, we can see the biggest of these times is 0.07915, and the smallest of these times is 0.07582. Let's take a look at the next row and see what it is. So all these look like 0.11, so here it looks like 0.1148 is the smallest, and 0.11746 is the biggest. So let's try and see if it comes up with those. Equals max, and I'm going to go back up, and I'm going to highlight those 3, close the parenthesis, hit enter, and okay, 11746, that's what we thought, and then equals, and then minimum, and I'm going to go back up, I'm going to highlight my 3 times and do minimum. Now the reason why we're doing this again is because we calculate uncertainty in this class, not using standard error or a more traditional way of doing it, but with a kind of quicker, easier, less mathematical way of just doing the maximum value minus the minimum value, so finding those two values, and then dividing by 2. So really what that does is it figures out what is the range in our data here, and that's it. So once I do that for a couple of them, I can actually fill down for all of them. And we can do a quick check. Numbers look appropriate. You can always double check them with up top. All right, so to calculate uncertainty, I'm going to say equals, and then I'm going to literally take my maximum. Sorry, one second. I'm going to put it in parentheses. I'm going to take my maximum minus my minimum, close parenthesis, divide by 2. The reason why we need parentheses is just because of order of operations. So I hit enter. I'll do this again. So equals, and then I'll say max minus min divide by 2. Oops, I forgot to put parentheses. And so we can see here that 0.06 seems huge compared to what we were getting before. Really small compared to what we were getting before. So I'm going to go ahead and put the parentheses back in. So it's usually a sign when something looks a little bit different than the rest of them, we just go back and double check for parentheses. We now have that in there. It looks like it was actually a big one, not a small one, misread. So now that we've got all of the max minus min over 2, we've got all of our uncertainties. And then for my own sanity, I like to just go through and I will highlight this data. I will use the reduced decimal places, reduce it down to 1 or 2 decimal places, and I'll just go ahead and write it up here for myself. So uncertainty is going to equal, it looks like 0.0086 is my biggest one, so I'm going to say 0.009 is my uncertainty. So I'm going to write it there just so I have it as a reference and I don't have to go back and find it. Alternatively, I could have used a max function to look through those data points and then have that set equal, and that is an option as well. That's it for this video. We're going to bump the linearization and graphing to the next video.